Now, as you've probably guessed from the title, in this video we're going to build ourselves a high gain antenna for 5G. Now, as of shooting this video, I've released 2 videos so far taking a look at the 5G antennas that are out there at the moment. I've still got 2 here in the lab that I need to take a look at. One's pretty good actually, and the other one is disappointing. But I haven't been impressed with them so far. They seem to have a really high price tag for what they are, and I mean, I was trying to bid on an antenna to get hold of so we can take a look at here in this channel, and it ended up going for £90. That's a second-hand antenna. Same antennas go for around £180 new, £150 around that area. Just a lot of money really. I think it's just a 5G price tag hype. Now, of course, because it's what I do mainly, I've decided to build my own high gain 5G antenna, and this is it, and this is the antenna that I'm going to show you how to build in this video here. You may recognize the overall design from a video, an antenna that I took a look at a few years ago now. Made a couple of builds on it, and I think the title was my new favourite antenna. So the design of this is based off of that antenna, and this antenna should give you around 9 dB of gain, especially if you use the same materials that I've used to build this here. If you want to use something slightly cheaper like tin, of course, then you probably reduce that by about 1 dB, maybe a little bit more. But yeah, I'm really pleased with this antenna, so let's get on with the build then, and I think you'll be really surprised at how well this performs on the network analyzer. Really is a lovely little antenna. Now, the material that we're going to use is brass. It's my preferred material to build an antenna like this out of, especially if we're not going to build a case over it. The electrical constant between brass and copper is only small, and to be quite honest, in the real world you're not going to see that difference. Now, of course, you don't have to use brass. This is an early prototype that I built off the antenna. This is just galvanized steel. This stuff here works just as well, although yeah, you can lose a little bit of gain using this, but again, if you just want to build one to try it out, then that's perfectly fine as well, or even old cookie tins, anything like that. Just be careful that you know, especially the thinner material you go, the less front to back ratio you're going to have, so you're not going to have all that forward gain in that one direction from there. And also, if you build it out of too soft a material, you have to think about protecting it really. And as always, we're just going to use basic tools to build this, nothing particularly special, just some calipers, a set square, and scissors, masking tape, and soldering iron, of course. Now, we'll include a template in the description along with all the measurements that I'm going to use. So what I'm going to do, I've got some masking tape on my brass here. I'm going to mark out the different segments of this antenna that we need to cut out of the brass. Once I've done that, we'll go over the measurements. Now, I've marked out everything on here so we can go over the measurements of this. Starting with the main driven element, it's 38.6 millimeters by 44.1 millimeters. Now, because we're going quite high in frequency, 3.3 to 3.8 gigahertz, you want to try and, you know, be as spot on with your measurements as you possibly can. You can also etch this out on PCB, of course, but try and be as close as you can with your measurements. 38.6 millimeters, 44.1 millimeters. The back reflector is 58 millimeters by 58 millimeters, and if you're out by a millimeter or two with the reflector, doesn't matter so much. The most important thing is this main driven element that drives the particular frequency that this antenna works at. So if you wanted to cut this out at 60 millimeters by 60, perfectly fine. 56, 55 millimeters, again, perfectly fine. Now, on this design, I've done 3 parasitic elements, these 3 circles here. If you want, you can just add 1 of these, you can add 3 of these, you can add 4 if you want to, get a tiny bit more gain again, probably a quarter of a dB. I've found that with this particular design there's a limit, and it drops off in performance when we get to 5 parasitic elements. I did a lot of experimenting with this antenna off camera a couple of years ago, and it does have a limit. So, you know, either do 3, 4 maximum, no more than 4 really. And the radius for those circles is 18 millimeters. Now, as for cutting this out, 5mm brass like this is soft enough to be able to cut out with a decent pair of scissors. Now, I'm going to cut these 2 out on the bandsaw. It's just really easier for me because I've got one, but you can use a pair of scissors to cut them out. For the circles, I am going to use a pair of scissors. I find that a lot easier than the bandsaw. My bandsaw is a pretty cheap bandsaw really. It doesn't handle small circles like this, ends up pulling the blade out. So I'm going to use scissors to cut those out, but just take your time and try and keep to these measurements as well as you can. As I say, this one here is the most important. Now, before you cut the circles out, it's a lot easier to drill the hole through the middle first, and I'm using here a drill bit. This is 3.2 millimeters in diameter, because we're going to fix all this together with some M3 nylon nuts and bolts. So as I said, really easy 5mm brass like this to cut out using a pair of scissors. Just take your time. And try and cut to the outside of the line, because we're going to finish it off with some sandpaper to get it all nice and smooth. Now I'm going to show you a little trick that works for the circles here. Now, you could use some sandpaper like this and just work your way around, moving it as you go, just to smooth out all those edges, but that takes quite a bit of time. Now, I only suggest you do this if you're used to handling a Dremel like this, but I've got a cutting wheel here, and I'm going to use that as a backing to give some support to the brass, because when you spin it up, this can deform and it can all end messy. So a little bit of support on the backing with this cutting wheel here, and I'm going to attach it to the end of the Dremel. Now, one thing I will say about doing this is a Dremel, and I haven't got a problem with the cheaper ones. I've got a few of them myself, but I find with the cheaper ones the speed controller here either goes from slow and you just touch it and then it's really fast. No real linear control in between here, so just be careful. I'm just going to set this off pretty slow. I'm not going to go over the top with this, just take my time. Got my sandpaper here, and I'm going to curve it slightly using my fingers, and then just slowly work it across, taking my time, smoothing the sides out. It's tempting to try and turn this up a little bit, but don't. I mean, at the end of the day, it's still a lot faster than doing it by hand. So now all I'm going to do is tidy up the sides, just deburr everything, get it all nice and smooth. Not taking a great deal of material off, just smoothing things out and tidying things up. So now we want to mark off to drill a hole through the centre of the reflector and the centre of the driven element, and the best way to do this is just to go from corner to corner and make a cross. So a little bit of masking tape there. And that's the centre. So what I'll do is just punch there and then drill a hole through again with the 3.2mm drill bit. And once we've got the hole drilled in the center, on the main driven element we need to drill a small hole for the feed for the coax. So I've got a 1mm drill bit here, and I want to measure in 7.5mm up from the bottom here. This is the longest length and this is the shortest length. So I'm just going to measure up 7.5mm, put a little mark and drill a little 1mm hole. Now I'm going to connect to this using some semi-rigid coax. You don't have to use semi-rigid, but if you want to stick this in, connect it to the back of the router for instance, just makes it a lot easier as far as you know, holding the weight of the antenna. But I've got a length here that's around 90mm long. I've got a SMA connector already soldered on the end. You can see how I've prepared this end ready to solder onto the antenna itself, but I'm also going to cover this with some heat shrink tubing like I have here, just to make it a little bit tidier. Now as you can see, I've already soldered the outer braid of this semi-rigid coax onto the back reflector, and I just wanted to share with you a tip. Something like this, which is a big piece of metal, is really good at sucking the heat out of your soldering iron. So you want your soldering iron turned up to the max, and if it's still struggling a little bit to get the solder flowing on here, use a small blowtorch just to get a little bit of heat into the metal first, not glowing red hot, but just to warm it up slightly, and then go in with your soldering iron, and your soldering iron will have a much easier job then of getting that solder to flow on there. Now we're going to start constructing the antenna, and I'm using these M3 pieces here. You can get a little box of assorted M3 you know, spacers and nuts and bolts from eBay pretty cheaply. So I'm using this threaded piece here. That's going to go through the back reflector. Now the main driven element wants to be 6mm away from the back reflector, and you can see here I've got a standard one here, spacer. This is supposed to be 6mm, it's showing 6.1mm on my calipers here. That's going to be fine. I've designed this to be 6mm away from the reflector. If you've ever played around with some of those online calculators, you know that messing around with that spacing there can really affect the frequency that your antenna works off. So if I were to space this at say 3mm, the measurements for this would be completely different. But I've designed this as 6mm because I know that this is the standard spacer size. So that's going to go onto this threaded piece here, and then the main driven element's going to sit on top of that. So now we're ready to solder on the main driven element. We've already pre-drilled that 1mm hole in there, and that's going to marry up with the inner core of our coax. You can probably see that I've also put some heat shrink tubing on that as well, just to make sure I don't short it out to the outer braid of the coax. You don't have to do that, but just be aware, just keep an eye on that, make sure you don't short it out. So now I've got to wiggle it into place to get that coax to go through the hole. Now that we've got the coax ready to solder in place, before I do that I want to clamp it down with one of the nuts. Now each one of the parasitic elements is spaced out at 2.5mm. Now I've chosen that for a reason, because the little nuts, the little nylon nuts that you get in a typical kit, is 2.5mm thick, which is perfect for spacing out those parasitic elements. Now be careful, measure them, because not always. I've got some here that are 3mm thick, so just be careful that it is 2.5mm, and again that's something that you have to stick to. If you haven't got any nuts, then little nylon washers will also work just as well. But I'm going to clamp it down with this nut and then solder our coax to the main driven element. And once that nut's in place, just check everything, that everything's nice and level, you're not shorting anything out. And this one's a little bit easier to solder onto than the back reflector, but again, soldering iron up full to solder it down onto there. And with any soldering job, just get the heat in there and feed your solder in. And with a soldering job like this, when you're dealing with something with RF, I don't like to leave little pointy bits like that sticking out. So I'm just going to get the file and just file it flat a little bit, just to tidy it up and get rid of that pointy bit. And now it's just a matter of building up the antenna and adding your parasitic elements. So again, just these nuts as spacers. And just trim off the excess of that threaded bar. And there we go, one finished antenna. And of course, if you want MIMO, really you're going to need two on your router, but let's take this over to the network analyzer and I'll show you what a fantastic little antenna this is. Now I have to say, what I'm seeing on the screen here, I'm really pleased about. I'm scanning from 500 megahertz over here all the way up to 4 gigahertz over here, and we're in this big dip here. This is the 5G band here. I'll move the cursor. We're looking at 3.1 gigahertz there, all the way up over here, 3.7, almost 3.8 gigahertz there. So from here all the way to there, that's the 5G band, and that's a beautiful response. And we've also got this secondary response over here, and this works from about 1.7 megahertz there, 1.8 megahertz down here, 1.9, 2 gigahertz there, 2.1 gigahertz. So we've got a really good response on the 5G frequencies, the 3 gigahertz frequencies there, and we've also got a really good secondary response on those mid-range frequencies for the cellular networks, around 1.7 megahertz to 2.2 gigahertz there. We're getting nothing on those lower bands, of course, you know, the around 900 megahertz, 1 gigahertz. It's not going to be very effective there, but I think these two responses here are more than going to make up for the fact that we haven't got those lower frequency responses there, especially in the 5G. If you've got a good 5G signal in your area, then use one of these antennas and your connection is just going to fly. I am really pleased with that. Now, as you just saw on the network analyzer, what a lovely little response in that 3 gigahertz band. This is an absolutely fantastic 5G antenna, better than anything that we've seen so far on this channel anyway, the ones that we've bought. If you built this, you would not be disappointed. And as I say, you can build this out of you know, just some tin or some galvanized steel like this one here. It's totally up to you, but brass is not difficult to work with, and you know, it's not that expensive to buy either. 5mm sheet like this, and an A4 size will be more than enough to build this for you. And again, it works really well around that 1800 megahertz, 1750 to around 2.2 gigahertz with that second harmonic. Doesn't work in those lower frequencies, but you know, if you've got a good stable 5G connection in your area, then why bother with those lower frequencies? Absolutely brilliant. I'm really pleased how this turned out. So hopefully this video wasn't too long, and I've included all the information you're going to need to build one of these for yourself. Not a difficult build, and not an expensive build either. You know, the M3 bolts and nuts and spacers, they don't cost a lot of money, and you can get an A4 sheet of brass off of eBay pretty cheaply. Doesn't cost a lot of money at all, no specialist tools, and you can quite easily knock a couple of these up in an afternoon. So if you did enjoy the video, please give it a thumbs up. Any comments or questions, drop them below. I'll do my best to answer them, and feel free to pop along to the Antennas Facebook group. There's always a discussion going off on there about antennas, and got any questions about this build, you can just ask the question there, and even if I don't pop along and answer your questions, somebody will. There's a lot of experienced builders on that forum, and if you want to help support the channel, you know, there's always Patreon, links below, and it just helps me build materials, so it helps support the channel so I can bring you builds like this. So as I said, if you did enjoy the video, please give it a thumbs up, and hopefully you'll join me on the next one.